All right. My name is Ed Green, and the fellow behind the camera is Robert Jordan. And what we're going to do today is go over the procedures for sampling water for the Boothbay Region Land Trust. All right. I like to think of this as two broad areas of observations. The first is the environmental observations, things like clouds, precipitation, wind speed, that kind of thing. And then the other aspect of what we measure is the qualities of the water, things like salinity, dissolved oxygen, and also pH. And we have meters to do that. So what we're going to be doing today is first we'll do the environmental considerations, and we'll be using a sheet like hopefully you have in front of you, which has areas that get filled in, and we'll do that, as I said, the observational aspects first, and then we'll go to the meters and show you how to use those and take readings. If you want to pan a little bit, we're at New Harbor, and this is Site 5 for the Boothbay Region Land Trust. And as you can see, it's a pretty place, lots of boats, a little bit of a breeze from that flag over there. And this is where we're going to be taking these observations. So first, and on this data sheet, is I guess the definition of the station number, site description. You need to put your name as to who you are as a sampler, that kind of thing. The next block is weather conditions. And the first one is cloud cover. So there are some options, 0, 25%, 50%, up to 100%. And today we have 100%, unfortunately, cloud cover. It asks you about precipitation. And the reason it asks you this is because when it rains, fresh water mixes with salt and it changes the salinity. So it says, is it precipitating now? The answer is no. Has precipitation occurred in the last 24 hours? And it has not. So we make those indications. The next one is wind speed. Now there is a scale in meteorology called the Beaufort wind scale, and that's for observational recordings. We do not have an anemometer cup, so we can't put a cup up into the air and measure it accurately in miles per hour. So in the back sheet that you have, and you can look at the details later, but there is a Beaufort wind scale, and it associates empirical characteristics, basically your guess as to what the wind, how fast the wind is blowing, and it associates that with a number. So if we can just pan on this harbor for a moment, it asks you for wind speed and direction. Now south, I often use a smartphone and the compass on it, but I know where south is on this, and it's out behind the island that has that red house on it. The boats very often point, the bows of the boats point in the direction that the wind is blowing. And today we have pretty much all the boats aligned. They're all pointing north. When we had a gust of wind, the flag was indicating the same. So, in that regard, we've got a north wind. The wind is very light. As I said, you can look at that scale that you have included in the package. But we're maybe 3 or 4 miles per hour from time to time. So I would give this a Beaufort number of 1. And again, we indicate that on the chart. It asks you, these are somewhat qualitative, but observations of the nature of the water. Things like, are there jellyfish present? Is there a lot of seaweed present? Do you notice other forms of life? We had some ducks floating around here, paddling around rather, a few minutes ago. So you want to annotate it. For this observation, there's no jellyfish. I've seen no fish, but there have been birds. There are certainly numerous boats here, and that can affect the quality of the water in terms of gas or oil being present. You might even notice that on the water itself. but I would indicate boats, a little bit of debris, and I would annotate this to say that in some locations there's seaweed present. So I will do that. It is also in this block for air temperature, but when we get to the instruments and how to use them, I'll show you where that thermometer is to measure air temperature. All right. We've covered the principles right now. Before I take a water sample, there's one more thing we want to do, and that's using something called the Secchi disc, and that measures water clarity. So let me get that right now. That's always included in the bucket that you have. And this is what a Secchi disc looks like. There's one important thing you want to do with this. This line is a little bit slippery. Sometimes the knot gets loose. And there have been occasions where people have thrown this in the water and noticed that the string is still in their hand and the Secchi disc has gone to the bottom. So give that a little tug and make sure it's taut. So how I do this is usually get some slack line. And today this will be easy because the current is not active and it should drop straight down. So for this particular site, the water is always clear and the disc always goes to the bottom. And right now it is on the bottom. So I make this a little bit taut and I get accurate reading. Just right there. Matter of counting to that point. So this is marked in, should be marked in tenths of a meter. And you see a red dot? That's 1 meter. That's 2. 3. So I have 4, 5, 3.9 meters. And while I do this, so on the back of that sheet that I was making recordings, observations rather, is an indication for that measurement. So, oops. So if you can get a shot of this. So this is the indication of the Secchi disc. It asks you if it hit bottom. And in this case, it did. If yes, and we had 3.9 meters. Now, if no, then you indicate the depth at which the disc disappears. And then you slowly begin to pull it up and the depth at which it reappears. So you have 2 readings to make if it doesn't hit bottom. But in this case, it's rather simple. When it hits the bottom, it's only 1 observation. So the next thing we're going to do is rinse out the bucket. Here again, it's always a good idea to make sure that this is tied securely. And you want to rinse out the bucket 3 times and then fill it up and use that as a basis to take readings with the instruments. So we're going to rinse the bucket in one location and then kind of move upstream and take the sample of water from, a distance of 4, 5, 6 feet away so that you don't have any contamination. All right. So this is just simply rinsing it out. And actually, I want to minimize the splash like I didn't do the first time. Okay, now what I want to do is, as I said, move upstream and take the sample away from that area where I rinsed. And if you can go down a little bit deep means like a foot, just so it's not all surface water, that's preferable. All right, so I think at this point we go to the second phase, and we're going to go back up where the instruments are. We're back. Let me just show you what the kit looks like, Robert, if you could just, and then we'll calibrate some of the instruments. So this is the kit. On this side, is the sensor for recording air temperature. And I'll show you how that works in just a minute. On this side, there's a little compass. And in case your smartphone does not have a compass, you can use this to determine wind direction that we did earlier. And there's a handy dandy clothespin to keep a probe away from other objects, and I'll show you how that works in a minute. All right, inside you have some wipes for drying objects, drying the sensors. Here are the 3 sensors. We'll go through how they work for each one of them, and there's also some solutions for calibrating pH. That's a 7, pH 7, pH 10, and you use those fluids, 1 green, 1 blue, as I said, to do the calibration. And I'll show you how that works in just a few minutes. Okay, so let me take the instruments out, and we'll line them up. And what I want to do is begin the air temperature reading. So, in order to do that, small switch here, that turns it on, and you can see that it came to life. This is the sensor, and I would give this a good 5 to 10 minutes out in the air before you record the temperature. It allows any heat that's been in your car to dissipate, and it also allows for a true reading. And I always put this in the shade. So one of the things you don't want to do, and I usually hang it over like this, is to leave that in the sun. And you don't want this probe, or the end of that probe, to be touching any object. That will give you a bad reading. And the clothespin is to secure that in case it can't hang freely. So, the first test we're going to do is for salinity, and here is the meter. You want to carefully remove this cover. So these are the electrodes. You want to be careful. You don't really need to touch those. One thing I always do, it may not be called for in the directions, but I always rinse these off. This is distilled water, just in case there was any contamination. Then you turn it on, And it's this button right here. And you wait for this to stabilize, which doesn't take long. Alright, two readings will occur on this. You'll get salinity, and you'll also get water temperature. Alright, you put it in the water, and just slowly move it around in the water, almost like you're mixing it. Make sure that the probes, the electrodes, are covered with water. You don't want to immerse this, but just enough to cover those electrodes. When the number stabilizes, right now I have 31.8, and I have 15.1 degrees. And as you can see, it's stable. Alright, those are our readings. 31.8 and 15.1. Alright, I'm going to rinse this off. Just dab this to dry it a bit. Put the cover back on. And again, turn it off. Alright. So now I will annotate the sheets. We had 31.8 and 15.1. So here is where the salinity reading goes. And water temperature was 15.1 Celsius. Next we're going to do pH. And as I said before, pH is an instrument that you have to calibrate. So with the salinity, it was pre-calibrated at the Land Trust office. However, for pH, we need to do the calibration on site, and that's what we're going to do right now. By the way, we have 14.5 for air temperature. It's been about 5 minutes on a cloudy day, so we can assume that that's pretty good. All right. So air temperature was 14.5. And again, that's degrees Celsius. All right. Now we're going to move to pH. So here's your kit. I think I mentioned before, part of the calibration process involves these two constant pH readings that we use for calibration. One is 7 and one is 10. Okay. Take the caps off. So, again, we take the cap off and be careful of the electrode. You really don't want to touch it. We rinse it with distilled water. And we turn it on. And that's the on-off button. So we're going to let those numbers stabilize a bit. And we're ready. So what we do, we insert this into the solution and we hit the cal button once. So first in the solution, then it says cal. And you've got to be a little patient here. And you see the 7, it's stabilizing or calibrating to the 7 solution. And pretty soon, hopefully, it goes to end. All right. We take it out. And it's important at this point to rinse it again, because you want to get all of that 7 solution off the electrode, because next you're going to put it into the 10 solution and do the exact same thing. It goes into the solution, then hit cal, and it says cal. And you can see it's stabilizing on 10. And it should say end. And it does. All right. We're going to rinse this off again with distilled water, basically to get that 10 solution off the electrode. All right, insert the probe into the water sample, and when it stabilizes, record the pH. So here we go. Here again, it's right up to the collar. And here again, you want to keep it moving. You don't want to sample one little spot. So we're up to 8. And we're still at 8. Basically we're done at this point, but I'll give it. Okay, 8.01. All right, we're going to turn it off, and we're going to rinse it. So, 8.01 was the number, and that goes right here. We are now on our last instrument. This is the test for dissolved oxygen. So we remove the protective cap, and you want to be real careful with this because the membrane of the sensor is delicate. So take it off slowly and remove it straight. You don't want to affect that. I'm going to put these caps on. Last thing I want to do is spill this. Okay, this is the membrane. And it says in the directions to inspect this for any tears, and maybe, more importantly, bubbles. So let's talk a little bit about bubbles. If you have those present, you'll get an erroneous reading. Just like in a bottle of water, when you turn it upside down, the bubbles are at the bottom and then they float back to the top. The same with this, there's a fluid inside. So when you inspect this, I like to hold it up and look for the presence of bubbles. Now sometimes it's difficult depending on the light because you're holding it up towards the sky, but if at all possible, you can kind of aid that. And I don't see anything. Looking for tears. So you can see a bubble, probably at 3 o'clock. But it will disappear when you hold it up because that bubble rises to the top. Okay. So, after that inspection, we want to turn it on. So you put the cap back on. And what you're doing is you're calibrating this to the air. So, with the cap back on, we hit the on button, which is this one. And then we wait for this, it says self-calibration. So we wait for the numbers to stabilize. And it says in the directions that this can take a while. All right, so this is set for a few minutes now, and it seems to have stabilized around 93.8 to 94 and 94.1, but anyway, we're at a point where we can begin. All right. So, it says press and hold the cal recal button until cal is shown in the display. And there's cal. And it will say, we're looking for SA followed by end. And we did that. All right. So the next step is to input the salinity reading that we took. Our salinity was 31.8. So we're going to input that into this meter. You press the cal recal button twice, and then you press the mode hold button as many times as needed to reach the number that you recorded earlier, 31.8. In this case, it's going to be 32. Press this twice. So I have to get to 32. So I'm toggling all the way up to 50, and then it will cycle back. So we're up to 10. And as I said, we had 31.8. And then we hit cal. And that locks it in. And it says end. All right. Through all that manipulation, we're now ready to take some measurements. Another thing you want to do is to make sure that you're measuring in milligrams per liter. So let me direct you to this. We're measuring in percent right now. So if you see numbers like 99.5, you're not in milligrams per liter. So in order to do that, you press and hold the mode hold button until milligrams per liter shows. So the mode hold is that top one. And now we're in milligrams per liter. Right above that 6.66, it says mg/L. We take the cap off, and we're ready to do this. Here again, the same procedure. Up to the collar, and keep it moving. And probably more important than any other meter, you got to keep this moving. Otherwise, the electrodes, if it sits in one spot, the electrodes burn up the oxygen in that one spot, and you get an erroneous reading. So we're at 723, and we're pretty stable. 727, and I'm calling that 727. It's stable. All right. Turn it off. Give this a rinse. And you want to be real careful with this membrane. I just hold this.
So you're not touching the membrane itself?
No, I'm not.
Okay.
Nope. Cap back on. All right, let's, yeah.
Okay.
All right, so we've included the reading, and you're going to notice something here that you have to do this twice. You may have to do it 3 times. I'm not going to repeat it for this video, but the reason being is that this is a tricky measurement, and you want to make sure that it's within the proper range. So if the first reading and the second reading is no greater than 0.6 milligrams per liter, you're fine. You don't need to do it a third time. However, if it differs greater than 0.6, then we ask you to do it a third time. And in this block over here, you do your first one, your second one, and then you do the subtraction and show the difference. So assuming that that's okay, you enter that. After you've taken that reading for dissolved oxygen, you rinse it off, you put the cap back on, you've shut it off, and then you begin the whole process again. And that whole process is to recalibrate it, to inspect it, to calibrate it, and then to take the sample. The last thing to do is basically to sign your name, give the end time, and turn it into the Land Trust office. All right?
Okay.